Hello, and in this video we're going to continue looking at exponential growth models, but in this case we're going to look at the model with a base of e, not the base of b. And we're going to relate it to the other model that we had before. This model basically uses a continuous growth method. So it's got a continuous growth rate instead of last time we had a growth rate based upon how many hours or how many years it took to grow that much. In this case, we're going to be doing a continuous growth rate every second of every day kind of situation. How much does it continually grow? All right, so here's the equation. This is your future value. This is your beginning value, the a sub 0. 0 just stands for time and 0. E is your base, not b. K is your continuous growth rate here, and t is your time amount. So those are your variables in this model. It looks very similar to the other one, and really if we had this model and we were just comparing it to this model, all right, if we were comparing, making comparison, basically little a would be a sub 0, capital A would be y, and e to the k is equal to b. That's how the two equations relate to each other. All right, but this one is used because we have a continuous growth rate. So when you're reading the problem initially and it says you have a continuous growth rate, then you're going to want to find that, or you may want to find your continuous growth rate. In this case, it says a culture of bacteria has a population of 500. After 3 hours, the population has grown to 800. Build an exponential function of the model that we have here. To model the population, use this to estimate when it will reach 200,000. What's the continuous growth rate? So it's asking us this question here. So that means we're going to need to use this formula because that's how we find k, which is the continuous growth rate. We're also going to use the other equation because it's going to want the hourly growth rate as well. So we can do both of those things. We can use both of these equations and find those two amounts. All right, so let's start with using the equation for continuous growth rate. So we're going to use a equals a sub 0, e to the kt, and we're going to try to figure out what k is. So a is, in this case, we're looking at the future value. In this case, the first sentence said we started with 500 and went to 800, so your future value is 800 and your start value is 500. We don't know what k is, but it took 3 hours, so we know what t is. All right, so my first step, as I've always done on all the previous ones, is to divide by this value in front. That's what I always do. Always divide by that value in front of the base. So in this case, I do the same thing. So I reduce, I get 8/5 equals e to the 3k if I rewrite it, so the k is second. Now I'm going to take the log of both sides, but I want to use the log that's going to deal with this base. So I'm going to use the natural log of this one instead of the common logarithm. The reason I do that is because the natural log of e are inverse functions, and they will undo each other. So these two things undo each other on this side. On this side, this gets undone, and we just end up with 3k here equals ln of 8/5. And then all we have to do is divide by 3 to get the answer. So in this case, my answer would be, let's get the calculator rolling here, ln of 8 divided by 5 divided by 3. So I get k as being, let's see, 0.1567, 0.1567. So that's 15.67%. So 15.67% continuous let's try again. Continuous growth rate. All right, so that's our continuous growth rate. Now there's a couple ways we can find our hourly growth rate. We also have to use this to estimate when it's going to reach 20,000. So let's do that next, and then we're going to do an hourly growth rate after that. So our next question is, when will it reach 20,000? So we can then go about the same process of finding the values for, let's move this down a little bit. So that's not in our way for our next problem. So let's go back to this one, and we're going to now find when it reaches 20,000. So instead of starting with 800, we're going to start with 20,000. We still have 500 to start with, but in this case we now know the continuous growth rate, which is 0.1567. But we don't know our value for t, so that's the value that's missing. Now this problem is exactly the same as this one in their steps, and we just changed our 800 to 20,000. So it's going to go about the same process. We're going to take and divide by 500. So we're going to get 40 equals e to the 0.1567t, and then we're going to take the natural log of both sides. We apply that natural log of both sides. We're going to get ln of 40. These are inverses, they undo each other, so we get 0.1567t on the other side, and we're going to divide by 0.1567 to get the answer. All right, so let's figure out what that is using our calculator. And then we're just going to verify it, make sure we have the right answer here. So ln 40 divided by 0.1567. So we get t equals 23.54, 23.54, and this is in hours, so a little less than a day to get to the amount of 20,000. So let's just verify this on our calculator here. So we're going to clear out the stuff we had from previously. We're going to put in the formula that we got here. 500 e to the 0.1567 x, and we're going to put in 20,000 here. All right, now we're going to set our window. This looks like 100,000, so we're going to have plenty of room here. 25 might not make it because we have to go to 23 here, so we're going to go a little further than 25 here. Our guess would be, let's go to 30 here. All right, and then we'll graph it. And I think we went a little high on this one, but we can still see it right there. So let's just reset our window a little bit better. We don't need to go to 100,000 since it only goes to 20,000. Let's go to 50,000. All right, it's a little higher up. Okay, now we'll do second calculate the intersection. First curve, second curve. We're going to go out to where we think it's going to be, close to 24 hours. And it gave us exactly the same answer. So very close to the same answer here. So that's how we would find that. Now, so we verified this. Now we need to answer the last question, what's the hourly growth rate? Now I think that we could do this by just using this part that I wrote up here. If I use this, and remember that B is equal to 1 plus the growth rate, then we can just use e to the k equals b and then rewrite it. So I think that that's what I'm going to do. Instead of doing all of that work here, I'm going to say e to the k. We saw that e to the k was equal to the base. If we look at the two equations again, we can see that they are very similar. These two are the same. E to the k is b and t is x. Forgot to write that in there, t equals x. So that's another thing you should know. So e to the k is b. We know k was this right here. So e to the 0.1567 is equal to b, which is in our case 0.1547. Sorry, 67. That's going to be 1.1696. All right, and that's equal to 1 plus the growth rate. So that means my growth rate is right here. So that's going to be 16.96% per hour. Is that our time increments up here? Yeah, at 3 hours. So 16.96% per hour, which should be higher than our continuous model. Our continuous is 15. 16. This is 1% more than our model for continuous, which makes sense because continuous means you compound more, so you need a lower rate. All right, so let's look at the second example here. I think this is the same type of problem actually. It just says if we can double in 5 years or 5 hours, what's the continuous growth rate? So this is a very similar problem. I would start off with 2 equals 1 e to the k times 5. And I would solve it the same way. Natural log 2 equals natural log of e to the 5k. These two drop out, so it's ln of 2 divided by 5 equals k. So following the same thing, that's what we're going to get. We can just find k that way. Now, so what I'm saying here is if we have a doubling problem, I think it's going to be ln of 2, always it's going to be ln of 2 divided by your time to get your k value. It's always going to work out that way to get your doubling thing. This has to be 2 because it's doubling. So your doubling rate would be found that way. And then we go back and do the same thing as we did before. We take our 3,000 equals 200 e to the, we would figure out what k is, ln of 2 divided by 5. In this case 0.1386. 0.1386 t. And we'd solve that just as we did before. So you can do that on your own.